another example on second shift theorem. Okay, let's solve the Laplace transformation of the function u t minus 3 t square minus 1. Okay, so here you have two functions. One of them is the unit step function. Okay, so what you want to do is you want to use the second shift theorem to find what is the Laplace transformation of this combination of two functions here. Okay, for your quick review, whenever you have u t minus a here, you will also have the other function as ft minus a. Okay, so you need to remember this one is the basic of this second shift theorem. Okay, now we want to use the second shift theorem, where the step number 1 for second shift theorem is to find what is the value of a. So how can you know what is the value of a? It comes from here in the unit step function itself, where your a is equal to -3. Okay, so your a now is equal to -3. So let it be in step number 1. So let's move to step number 2. In step number 2, you need to know what is your ft, because whatever comes with this function here is actually ft minus a, means that you have in the equation is ft minus 3. Okay, because you have ut minus 3 here, means that the other one here is ft minus 3. So ft minus 3 is equal to t square minus 1. You don't want ft minus 3, you want only ft. So what you should do from ft minus 3 to get ft is you need to plus with 3, because -3 plus 3 is 0. Therefore, whatever t in the equation on the right side, you need to replace it by t plus 3. Okay, so what you will have here is replace t with t plus 3, so you have power of 2 here minus with 1. Okay, therefore your ft now, let's expand this equation. You will have t square plus 60 plus 9 minus 1. Therefore your ft is equal to t square plus 60 plus 8. Okay, this one is step number 2. Okay, let's move to step number 3, where in step number 3 you need to find what is your fs. So what is fs? Fs is the Laplace transformation of ft. Okay, so Laplace transformation of ft is equal to fs. Therefore, to find fs for this equation, we need to find what is the Laplace transformation of our ft, where ft is equal to t square plus 60 plus 8. So by using the linear property, Laplace transformation of this equation can be written in the form of Laplace transformation of t square plus with Laplace transformation of 60 plus with Laplace transformation of 8. Okay, and for this one you need to use the formula of n factorial over s n plus 1, as well as this one also n factorial over s n plus 1, and this one is the Laplace transformation for constant a over s. Okay, therefore what we really have as a fs here is 2 factorial over s power of 3 plus with 6 times with 1 factorial over s to the power of 2 plus with 8 over s. So you will have 2 over s to the power of 3 plus 6 over s to the power of 2 plus 8 over s. This is our fs. Okay, let's move to the next step, or the final step in second shift theorem, where you can find the Laplace transformation of the whole function u t minus 3 t square minus 1 as exponent as dot fs. So you know that from step number 1 your a is equal to -3, therefore you will have exponent -3s times with your fs here. So just put a bracket 2 over s to the power of 3 plus 6 over s to the power of 2 plus 8 over s. Okay, therefore you will have 2 2 exponent negative, or you can left the answer like this. Okay, so this is to find the solution of your Laplace transformation by using second shift. Okay class, so let's see another example on second shift theorem, where we have to find the Laplace transformation of function u t minus phi times with sine t minus pi. Okay, therefore we know that whenever we have the function u t minus pi here, okay, the rest of the function is actually the function of f t minus pi. Okay, so the first step to solve this by using the second shift theorem is to find what is the value of a. So from here you know that the value of a is equal to negative pi. Okay, so your a here is equal to negative pi. Okay, next step is to find what is your ft. Okay, you know that from the function here you have your ft minus pi is equal to sine t minus pi. So now you want only ft, so what you should do is you need to eliminate minus pi. So how to eliminate minus pi? You need to plus with pi. Therefore, whatever t appears in the equation on the right side here, you need to replace it by t plus phi. So what you have here is sine t plus pi minus pi. Okay, therefore you will only left with sine t. Okay, so now we move to step number 3, where in step number 3 we need to find what is our fs, or the Laplace transformation of ft. Okay, so we know already that our ft is equal to sine t, therefore fs is equal to the Laplace transformation of sine t, where we can find by using the formula of a over s squared plus a squared. Okay, where here our a is equal to 1. Okay, our a here is equal to 1. Therefore, what we will have here is fs equal to 1 over s squared plus 1 squared equal to 1. So this one is our fs. So now we already know what is our a and our fs. We move to step number 4, where to find the Laplace transformation of u t minus pi, sine t minus pi is equal to exponent as dot fs. We know that our a is equal to negative pi, therefore we have exponent negative pi s, and our fs is equal to 1 over s squared plus 1. Therefore our final answer is exponent negative pi s over s squared plus 1.